Okay, so let's continue with chapter 10 after finishing 10.1, which is about solving systems of two linear equations. We're about to do systems of three linear equations. Three linear equations in three variables. So when we talk about one equation in three variables, now we have x plus y plus z. We have a plane in the space. In other words, if x and y are 0 and z is 4, if x and z are 0, y is 4, if y and z are 0, x is 4. So if you have that third dimension, z, x, y, you get three intercepts at 4, and you get what we call a plane in space. And that plane is in space is like a sheet of paper floating around the room, but it doesn't have ending like this. It's like a line. Remember, the line doesn't end where you stop drawing. It just keeps going. So what if we have three of those? So to solve a system of three equations, we're not going to do graphing, of course, not for 3 by 3. To solve a system of three equations, again, the steps are a handout, so I'm not going to write down all this. It's pointless. I'm going to show you an example as I read the steps for you. So solve the system, and we're mainly going to do elimination, okay? Could do some substitution, but mostly elimination. 2x plus y minus 2z equals negative 7. I'm going to label them equation 1, equation 2, x plus y plus z equals negative 1, and equation 3. So it's in the yz plane, it doesn't have an x value, okay? So the first thing you want to do is write all the equations in standard form, clear of decimals or fractions. So you can xyz constant, xyz constant, 0xyz constant. That's what they mean. Choose a variable to eliminate, then choose any two of the three equations and eliminate the chosen variable. If you look at equation 3, it's already x free. There's no x there. So the choice has already been made for me to eliminate x because I already have one equation that has y and z. I need another equation to eliminate another equation with y and z, because the idea is to reduce the three equations in three variables into two equations in two variables, and then we will use what we learned in section 10.1, namely addition or substitution, to solve that system. Okay, so that's the idea. So this has already been eliminated x from, so we're going to use equations 1 and 2 to eliminate x, and again, but to do so we're going to times first equation 2 by negative 2, so we can have negative 2x, and we already have 2x there. So we're going to say negative 2 times equation 2, and we're going to do the math over here. Negative 2 times x, negative 2 times y, negative 2 times z, negative 2 times negative 1, and then we're going to bring down equation 1 as is, minus 2z equals negative 7. So negative 2y plus y is negative y, minus 2z, negative 2z minus 2z is minus 4z, 2 minus 7 is negative 5. And then we're going to, so this is usually going to be equal to 4, and then bring equation 3 down, negative 2y minus z equal negative 3. So after we get that, then select a different set of two equations, eliminate the same variable. This was already done for us. Solve the system of equations from steps 2 and 3 for the two variables. So you can use addition or elimination. If I want to use addition, I would have to times the top equation by negative 2 to make it 2y. Do the math over here. Negative 2 times negative 4z is 8z. Negative 2 times negative 5 is 10. So we get 7z equals 7. So we already got 1 out of 3. Remember, we need 3 values. Z is 1. We go back to the immediate equation, 4 or 3. Which one of them? Either one of them. So I'm going to go back to equation 4. I already have z equals 1. Go back to equation 4. negative y minus 4z is negative 5. Negative y minus 4 times 1. Negative y minus 4 is negative 5. So y is 1. So I already have z and y. Now I go back all the way back to either one of these three equations. I'm going to go to equation 2. It looks easier. X plus y plus z equals negative 1. So I'm going to put a 1 for y and 1 for z. 1 plus 1 is negative 1. X plus 2 is negative 1. Negative 1 minus 2. And then write your answer as an ordered triple. X, y, and z. Okay, so the system that we just saw had one equation already done for us. Let's do one from scratch. Example 2. Again, how do we solve the system? Equation 1, it's x plus 3y minus z equals 5. Equation 2, negative x plus 2y plus 3z is 13. And equation 3, 2x minus 5y minus z negative 8. So it looks like if we scan through x, y, and z, it looks like x would be the easiest because I already have x and negative x. So if I add equations 1 and 2, add 1 and 2, x's will cancel out. I would have 5y, and then negative z plus 3z is plus 2z, and 5 plus 13 is 18. So this is my equation 4. So since I've already used equations 1 and 2 to eliminate x, I'm gonna either use 1 and 3 or 2 and 3 to eliminate x. Again, you gotta eliminate the same variable twice. If I use 2 and 3, all I have to do is times the second equation by 2. So I'm gonna say 2 times equation 2, 2 times negative x, 2 times 2y, 2 times 3z, and 2 times 13 is 26. I'm going to bring down equation 3. X minus 5y minus z is negative 8. That cancels out. 4y plus negative 5y is negative y. 6z minus z is 5z. 26 minus 8 is 18. So we already used equation 4. This is equation 5. So now I am going to bring equation 4 down. But before I bring it down, I want to use elimination. No, so let's put it down here. So if I want to use elimination, I gotta times the top equation by 5. Do them over here. Negative 5y plus 5 times 5z is 25z. And 5 times 18 is 90. That cancels out. 27z that's 90, that's 108. And z is 4. So we got 1/3 of the answer. Now once we get d, then we go back to equation 5 or equation 4 because they y and z. We plug in z4, then we get y. So I'm going to go back to equation 4. Z equals 4. I'm going to go back to equation 4. 5y plus 2 times 4 is 8 equals 18. Move the 8 over. And then y is 2. So I have z is 4, y is 2. I'm going to go back to equation 1. X plus 3y minus z is 5. Right there. So x is unknown. 3 times 2 is 6. Minus 4 is 5. X plus 2 is 5. X is 3. So 3, 2, 4, my solution. Alright, next one is going to be different. So let's see how different it is. Example 3. Solve the system. Equation 1. 2x plus y minus 3z is negative 3. 3x minus 2y plus 4z is 2. Equation 3. 4x plus 2y minus 6z is negative 7. It looks like, I think the easiest, unlike what I did in my notes, the easiest is to eliminate y, so I would add equations 2 and 3 without doing any other work. 2 and 3. 3x plus 4x is 7x, the y's cancel out. 4z minus 6z is negative z, 2 minus 7 is negative 5. So this is equation 4. So I've eliminated y using 2 and 3. Now I'm going to eliminate y using 1 and 2. First timesing equation 1 by 2. So times equation 1, it would be 2 times 2x, 2 times y, 2 times 3z, and then 2 times negative 3. And then we're going to add it to equation 2. 3x minus 2y plus 4z is 2. That's 7x minus 2z, negative 6 plus 2 is negative 4. So this is equation 5. I'm going to bring equation 4 down here. 7x minus 2z is negative 5. If we times this by negative, put the work down here. Plus 2z is 28. So we get 0 equals 23. So this is inconsistent, meaning the three planes have nothing in common, no solution. Okay. So let's see a case where we have infinite solutions. Example 4. Solve the system. Equation 1. 3x minus 2y plus z equals negative 1. 2x plus y minus z is 5. And then 10x minus 2y is 8. So you can see equation 3 has no z, so we already have an equation that has x and y. We're going to add equation 1 and 2 to eliminate z to have x and y again. So add 1 to 2. 3x plus 2x is 5x. Negative 2y plus y is negative y. Z's cancel out. 5 plus negative 1 is 4. We're going to put equation 3 down here. 10x minus 2y is 8. So we're going to times this by negative 2 to do elimination. Negative 10x plus 2y is negative 8. And everything cancels out, meaning we have dependent system and it's infinite solutions. But remember, when it's infinite solutions, it's not enough to just say that. You have to write the general form. So to write the general form, you want to write two of the variables in terms of one of them, in terms of the other one. Okay? Two of them in terms of one of them. So it looks like it doesn't really matter. It looks like if you look at this third equation, it looks like we can isolate y. So we're going to write y in terms of x. So 10x minus 2y is negative 8. 10x plus 8 equals 2y. So we got 5x plus 4 equals y. So y is 5x plus 4. Look what that means. That means x is x. Y is 5x plus 4, and then z has to be in terms of x. You have to have all three in terms of the same variable. If I find y in terms of x, and then I put x for x, 5x plus 4 for y, and then I need z in terms of x. So we're going to go back to the first equation. Remember, x is x, y is 5x plus 4, and we want z in terms of x. Okay, so 3x minus 2y, we're going to put that for y, plus z is negative 1. Distribute, x minus 10x minus 8 plus z is negative 1. So that's negative 7x minus 8 plus z is negative 1. So z is 7x, add the 8, you get plus 7. So x is x, y is 5x plus 4, and z is 7x plus 7. So now you can plug in any value for x. You can plug in 0, and that's going to give you 0, 4, 7. You can plug in 1, and that's going to give you 1. 5 plus 4 is 9, 7 plus 7, and so on. You can generate infinite solutions. Okay. Y equals 5x plus 4. Oh, it should be minus 4. I made a mistake. Okay. Just 10 minus 2x equals, oh, it should be 8. I put negative 8. That's my mistake. So plus. So this should be minus, minus, minus. Let's fix that. The notes are right. So it's just, so this would be minus, and this would be 7x minus 9. Follow the notes. Okay, it should be minus, plus, plus, and then it would be 7x minus 9. Yeah. Okay. So look at the notes. Number 40, page 697. 40, page 697. Let's see what's in 40. An application question. It says Cindy wants to invest 50 grand. Her financial planner advises her to invest in 3 types of accounts. One paying 3%. So it's about simple interest. Principal times rate times time equals interest. There's 3 different accounts. Okay. One paying 3%, 0.03, one paying 5.5%, 0.055, and one paying 9%. Simple interest per year. Cindy wants to put twice as much in the lowest yielding, least risky account as the highest yielding account. So let's call them first account, second account, and third. How much should she invest in each account to achieve a total annual return of 2540? So the total, she wants 2540 from the interest. Okay, that's what she wants. So how much should she invest in each account? And she has 50,000 to invest. So x plus y is the amount that the total amount invested is 50,000. Now, but we're talking about 1 year, so the interest she's going to earn from the first account is 0.03x, if you times principal times rate times time. This would be 0.055y. This would be 0.09z. So add them up. Plus 0.055y plus 0.09z should add up to 2540. Okay, but we need a third equation. The equation is right there. It says Cindy wants to put twice as much in the lowest yielding account. This is the lowest yielding account. Least risky as in the highest yielding. This is the highest. So it should be, x should be twice as much as z. Okay. So there is 3 equations, and I want you to get rid of the decimal and solve it. Okay. I might have a question on the test where you have to set it up and solve it. This shouldn't be too hard to solve. And that ends 10.2, and that's where the test is gonna go up to. Okay.